Hi guys, this is Dr. Karim Amir, Book. Today I'm going to introduce a new course from ASHRAE, HFDP or Healthcare Facility Design Professional. The course consists of 10 lectures, around 20 hours. It's based on the references mentioned in ASHRAE Candidate Handbook, like 170 standard for ventilation of healthcare facility, FGI Institute guidelines, CDC HVAC manual for hospital and clinics, and NVA 99. So today we're going to giving you intro about the course exam overview. So what is HFDP? Who should take it? Why you take it with book? Exam overview and the eligibility requirements, the exam blueprints, exam sample questions, the course content or schedules, still lectures, basics of HC facility or healthcare facilities, standard guides, HVAC systems, energy sustainability, infection control, utilities, fire and life safety, control systems, emergency management, operation and maintenance. Then we talk about the outcome of this course and certifications. So what is HFDP? It's a healthcare facility design professional developed by ASHRAE to validate competency of professionals to apply codes, standards, and the principles of HVAC design in healthcare facilities. As you know, ASHRAE provides different certifications in design, performance, and operations. In design, there are 4 certifications: PMP or Building Energy Modeling Professional, CHD, Certified HVAC Designer, HFDP, Healthcare Facility Design Professional. Today we're going to talk about it. And HPTP for High Performance Building Design Professionals. In performance, 2 certification, BCXP for commissioning, PAP for energy audit or energy assessment. In operations, 1 certificate, OPMP. And in decarbonization, there is CDP certification. So HFDP is accredited under ISO 17024, and it's globally recognized as a professional in healthcare facility design, especially HVAC systems. Who can apply for it? HVAC designers, especially in HC facilities, healthcare facilities, and the building service engineers, MEP engineers, and architectural engineering, facility or building maintenance engineers, biomedical, clinical, and healthcare engineers, because there are some parts about medical equipment, operation and maintenance, and any professional who work in healthcare facility design, especially HVAC, and he can provide proof in the application through ASHRAE website. So why book? The qualification of an instructor as a PE, chartered engineers, and has experience in HVAC design, especially in healthcare facilities, academically and practically. The content or body of knowledge for the course, it's informative and simplified, based on learning, knowledge, and the exam. Delivery can be live virtual for group and corporates, or recorded videos plus a mock exam for individuals. And there are interactions and support throughout your study journey till you pass the exam from first attempt. Exam overview, it's a multiple choice question, MCQ, 115 questions, 100 questions scored and 15 unscored. Duration of exam, 2.5 hours for native English speakers and 3 hours for non-native speakers, but you have to claim it during your application for the exam. Exam policy is closed book, not allowed to bring any reference or book in the exam, just calculator and psychometric chart if required. Time and location for the exam. Based on your location and the preference, you can apply and mention your city and find center at preferred time. Eligibility, if you have PE license, just 2 years of experience. If you don't have and have bachelor degree, you need 5 years of experience. If you don't have and you have associate or technical degree, you need 7 years. If you don't have and you have high school or diploma, you need 10 years of experience. Registration for the exam costs $495 for members of ASHRAE and non-members $745. If you are from developing countries, you can just pay $295. For exam retake, $220 for members and $285 for non-members. Certification is valid for 3 years. To pass the exam, you need 75% score, and passing rate till date, it's 78% of all candidates for the exam. Blueprint for the exam as per ASHRAE Candidate Handbook. The first part about medical background, you have to have many basics and background about medical terminology, equipment, department in the hospital, airborne and direct contact disease, infections, and pathogens. Second part about standard and guides. Third part about HVAC system design for healthcare facility. And the last part about unique requirements like infection control, disaster, life safety, and so on. So how the exam question looks like. This is for the current year exam. The first question, it was about airflow in protective environments, PE room. This room should be positive to protect the immunocompromised patients from any infections. So it should be positive, so the airflow from the patient room to the corridor. Second question about here, NV reference dedicated to ventilation of medical gas storage. It's NV55. Third question, compliance with ASHRAE standard 90.1 for energy efficiency of building. Mandatory provisions for heating, ventilating, and air conditioning can be achieved through prescriptive baths or alternative baths. Alternative baths may be cost budget, energy cost budget, or performance rating. So here the second option will be prescriptive method. Question number 4 about airborne infection isolation room or AII room. This is negative pressure patient room for people with infections. So in order to prevent these infections to spread in the hospital, you have to provide negative pressure. Diseases includes TB, tuberculosis, measles, and so on. So the best option here to be measles. Last question here about airflow calculation inside patient room. The patient room here is AII, so it's negative pressure. So here, let's demonstrate this room. So here, the volume of the room, 1,100 cubic feet, and the required minimum supply airflow air change per hour 12. So here from the volume and air change per hour, you can get the CFM by the equations. Air change hour, volume, cubic feet by 60 equals here around 220 CFM. So this supply for AII room, 220. Airflow across the door to maintain pressurization is 150. So here, this patient room, this is a corridor. So it's negative pressure. The corridor should be positive for this room because it's, as we said, AII has here infectious or contagious disease from the patients. So the flow air should be from the corridor to the room. So here undercuts permissible here for the healthcare facility. Here to allow to pass 150 CFM. Leakage and toilet room exhaust is 130. So if we here is toilet room, the exhaust here is 130. Generally, toilet room should be negative for the whole patient room. So here 130 exhausts, 220 supply to the room, and 150 transfer from corridor to the room. So here, what is the size of airflow exhaust fan serving the patient room? So here he needs the exhaust airflow from the patient room. So here 220 supply plus 150 transfer equals 370. This should be exhausted from the room plus 130. So total exhaust will be 500. So here he just need exhaust from patient room, so it should be 370 to maintain negative pressure inside the room. So 500 is total, but 370 is the right option because it's only for the patient room. As we said here, the course content, 10 lectures, 10 days. So the first day, it will be about the basics of healthcare facilities. We have introduction about healthcare facility classifications, HVAC system function, hygienic, criteria, accreditation, sustainable design, equipment sizing for healthcare, for heating and cooling loads, integrated design and commissioning. So here, to have a basics of HC facility or healthcare facility, you need to go through or walk through the hospital and understand the departments and rooms inside the hospital. So through the course, we will walk through inside the hospital and identify different departments, starting from the lobby, receptions, corridors, AI room, PE room, operating room, pharmacy, labs, endoscopy, and so on. Example here, main lobby, cafeteria, reception, nursing stations, intensive care units, operating room, endoscopy suites, cath lab, MRI, or X-ray, or CT scan, and so on. So you have to understand that you need to have overall basics of healthcare facility. So here we'll discuss the classification of healthcare facility based on HVAC design manual for hospital and clinic and NFA 101. Accreditation agency like Sabahi in Saudi Arabia and different agency in USA, Canada, Australia, and so on. What is the function of HVAC system and ASHRAE weather data viewer for climate zone and calculation of heating and cooling loads. Second day about standard guides, ASH standard 170, FGI guidelines, CDC, NV 99, HVAC design manual for healthcare for hospital and clinic, and other reference like NB 101, 72, 13, 55, and ASHRAE standard like 15 and 34, 55, 90.1, 62.1. Here is the main standard, ASHRAE standard 170. Here it covers the whole rooms and department inside the healthcare facility, including pressure requirements, minimum outdoor air exchange per hour, total air exchange per hour, if it's allowable or not to have circulation units inside the room, unoccupied turn down for the room or no, and humidity, RH percent, temperature, and filter rating. FGI guidelines mainly about space planning for different inpatients, room, isolation room, operating room, and so on, and different areas in the hospital, restricted, semi-restricted, and unrestricted, and CDC guidelines for infections control, HVAC design manual for hospital and clinic, and NVA 99. Third day about HVAC systems, introductions, basic psychometric heat transfer, air and water, and the fan, laws, power, pressure, and flow rates. AHU component like casing, filter, energy recovery, UV radiation, fans, and so on. And air distribution systems like duct, air diffusers, supply, and grills for return. Here, the casing and classifications, mechanically leakage filtrations, different types of filters, pre-filters, either bag, second stage filter, final filter like HEPA filters, UV radiations, configuration of cooling coil with fan and filters, draw through or blow through. What is the advantage, disadvantage, pros and cons for each. Here's a fan curve, the recommended area, far from surge, and affinity low for the fans, including the power requirements, protection for the cooling coil, like hydroxide coating in harsh environments to prevent corrosion, different type of air outlets or inlets, especially in operating room, we require uh, group E or laminar unidirectional non-aspirational diffusers to provide air curtain and laminar flow under low velocity, approximately 25 to 35 feet per minute. Day number 4, energy sustainability. We have introductions about energy sustainability, energy efficiency measures, especially in HVAC systems, lighting, plumbing, and so on. ASHRAE standard 90.1 for energy efficiency, prescriptive and cost budget methods or performance rating. If you need more efficiency, like 30%, 50% more than standard, you can go to Advanced Energy Design Guide by ASHRAE for large hospital and small hospital. How to calculate economic analysis like life cycle costs, return on investment, and simple payback periods, energy end use and metrics in hospitals. Day number 5 about infection control, microbial pathogens, different types of virus, bacteria, parasites, fungi, and so on. Different type of filtrations and locations, room design, especially positive, negative, and operating room. How the infection here spreads from person to person and from the reservoir or source to the host, a chain of infections, different type of pathogens and infections, airborne, waterborne, or bloodborne, or surface, direct and indirect, size of particles, and selection of recommended or filters MERV rating as per ASHRAE 170, how to calculate CFM based on air change hour requirements and the pressure agent in the room, CFD analysis for different locations of supply and return diffuser and grills, utilities, especially center plants for mechanical, electrical, medical gas, domestic, hot water and cold water, private and public utilities, difference between them, redundancy, reliability, and N+1 configurations, configuration for essential power as per NVA 99, 101, and 110 for the alternate source, medical gases like oxygen, nitrous oxide, medical vacuum, nitrogen, carbon dioxide, medical air, and anesthesia gas disposal system, water management program or plan for the hospital. Day number 7, fire and life safety. Introduction about life safety features, fire rating and smoke compartment, smoke zone, fire barriers, smoke control, passive and active, fire suppression, water-based, non-water-based, fire detection and alarm, and evacuation, eradication, and fire drill plan based on the concepts defend in place or shelter in place. Here, comparison between passive and active systems, smoke control, clean agent if required in any plant room or any specific room in healthcare facility as per 101 requirements, fire evacuation plan based on defend in place concepts, FSU, different initiating and supervising notification devices, appliances in firearm system, sprinkler system requirements, and joint commission life safety standard. Day number 8 about control system basics, about components, hierarchy of control from management level to field device level. Input, output, either binary, digital, or analog. Room pressurization control and operating room control. Here's the hierarchy: management level, automation level, application level, field control level, EDC and backnets as per ASHRAE standard. Component of control system starting from sensor input, actuator, output, controlled variable, and so on. Different types of monitor for pressure, positive or negative, in order to alarm nursing about any default in the isolation rooms. Day number 9 about emergency management, hierarchy of hazard control from elimination to PPE, disaster preparedness plan, critical needs for healthcare facility and emergency power systems. We start here with disaster preparedness, from prevention to preparedness before the event and after the event, response and recovery. We have different disasters, internal, external, like chemical, biological, radiological, nuclear, and other natural disasters like earthquake, flooding, hurricane, tornado, and wildfire. Sterilizations here using HEO or hydrogen peroxide and another autoclaving by steam. Hazard hierarchy from in relation to PPE. Last lecture about operation and maintenance. We have the risk assessment for infection control, commissioning, operations, and different types of maintenance, reactive, unplanned, planned, based on reliability center maintenance, to choose between reactive, preventive, predictive, and proactive maintenance based on the required criticality for the equipment. Here, different instrumentation for airflow, pressure, and temperature or humidity. For example, for pressure, we're using micro manometer. For airflow, we're using vane anemometer or volume flow hood. For humidity, hygrometer, and for temperature, maybe thermal camera or thermometer. Here, for example, for the maintenance, when you replace the HEPA filter, recommended to use back in, back out to protect the maintenance technician from the pathogens. And here is the tab, testing, adjusting, balancing for air and flow, air and water flow. So based on this course, you will have the knowledge to be competent in design, construction, and operation of healthcare facility, have the necessary and required knowledge to pass the exam from first time. You will be distinguished among your peers, client, and employers if you get the certificate and badge. You'll have more opportunities to be employed or hired to top employers, especially in healthcare facility fields. And you'll be globally recognized and certified, as ASHRAE is globally recognized organization to provide this kind of certifications. Finally, if you have any questions, you can contact us through the websites or YouTube, email, WhatsApp, LinkedIn, Facebook, and you can directly contact me if you have any other question. Thank you, guys. See you.